Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super. Today's incident, we're going to focus on a zonal power issue that impacted part of one availability zone within South Central US in one of our regions.
That's right. This issue impacted customers on the 26th and 27th of December 2024, and it was just over 24 hours for some customers, so a bit of a long tail recovery there. With that, let's introduce our 9 guest speakers that we have to run us through the different elements of the outage.
It's a big panel today. Starting with, we have Michael Martin from our data center operations team.
We have Jagan Devaraju from our Azure storage team.
Super. We also have Lehua Huan from our Azure networking team.
Also joined by Binit Mishra from our Azure compute team.
Debashri Bawar from our Azure Cosmos database team.
As well as Ajay Kalhan from our Azure SQL database team.
Karthik Motialla from our Azure Synapse team.
We have Manish Kumar Jain from our Azure Site Recovery team.
It's a big breath. And finally, we have Yunus Mohammed, our Corporate Vice President and Distinguished Engineer, talking to us about resiliency and zones.
That's right. So we've got a lot to get through today. We like to think that incidents are really a team sport. We don't want, a deep dive from one team here. We really want to hear from all the different players involved. So Michael, I think we'll start with you because this was initially an issue in our data centers. Thank you for representing our data center operations team here. Now, data centers lose power. That's a thing that happens for lots of different reasons. I understand this wasn't an issue with the utility upstream. This was a ground fault, faulty cable. Would you talk us through that initial trigger event and ultimately how our batteries let us down during that transition?
Yeah, David, thank you. And I want to start with, our mission in operations is to provide secure and available services to our customers. And we let our customers down, and this disruption is impactful. So we're working diligently to learn everything we can and share those learnings to our fleet and prevent recurrence. So what happened? So SN7 is a 3 data hall building that completed construction in January 2022. That was when data hall 3 was last delivered. It actually, the first data hall was given to us in July of 2020. On 26 December at 1840 UTC, which is about 1240 local time, a power cable feeding our building failed. And this is failed at a connection at an underground fault. And this caused a short, as you said, a ground fault, and an inrush of current tripped our main supply breaker powering the building. And this is operated as designed, what we wanted to happen if in response to the failure. And this could have been any loss of utility. And on those losses of utility, we rely on our uninterruptible power supplies, or UPSs, to provide battery power temporarily while our emergency diesel generators start and provide power. This takes less than a minute, and this is considered a graceful transition to generators. So data halls 1 and 2 completed the transition as designed, but the UPSs failed in data hall 3, resulting in a loss of power to the devices housed in that data hall. So the failure of the UPSs was due to rapidly degraded batteries in those UPSs, and they were unable to maintain power and shut down before the generators started as designed and were ready to assume the load. So initially on the event, the team investigated the transition to generators, noted that the data hall 3 had lost power, and there was a period of time that we had to go evaluate conditions, make sure it was safe to restore power. And restoring power was a very manual procedure on several different switchgear rooms in data hall 3. And then we shifted, once we restored power in less than a 2-hour period, our on-site teams then monitored diesel generators until we ended up restoring to utility. So hopefully that makes sense on the initial cause and the fact that it was related to batteries.
So I'd love to double click on something. You spoke about the degraded batteries. What happened there? What did we learn about this? How did they get into a degraded state? What are we going to do moving forward?
Yeah, no, great question. And again, these are voltage regulated lead acid storage batteries, the VLRA batteries. Think of similar to a large car battery, but much more robust. And in these UPSs, there's 5 strings and there's 40 batteries per string. So about 200 batteries per UPS. And in a data hall, we have 8 UPSs, so 1,600 batteries are distributed through the different UPSs in there. So we do multiple monitoring of our battery systems. We have a continuous monitoring systems, we have capacity test discharge, and we do simulated power tests where we actually see the whole system work and we transition from a simulated power loss to generator with the batteries carrying the UPS. So we completed our testing in February of 2024 with in all 3 data halls without issue. And then we capacity tested our batteries in data halls 1 and 2 later in the year. And then we were scheduled actually for testing data hall 3 in January. Obviously, the event occurred. This is a great indication of the capacity of the batteries to maintain load for the transition. Now, to keep the strings healthy between all that testing is we have a battery monitoring system that checks for degrading voltage and impedance, or this is internal resistance in the batteries. And what we saw was that the batteries in data hall 3 were experiencing a rapid increase in impedance and were failing at a rapid rate compared to the other data halls. Now, our technicians go through our standards. They go to test the batteries locally when we get an alert prior to replacing the batteries. And the monitoring system was showing a high resistance, a relatively high resistance, and then we locally tested it, we were getting a much lower resistance. So they did not replace these batteries when they saw the lower resistance. They did replace several and many that did show matching resistance with the battery monitoring system. Now, this disconnect between the battery monitoring system and the local testing it needs to be investigated. There's a requirement to submit a work order to do this local testing. This was not done by the local site teams. They drifted from the procedure. And these work orders are key indicators to the business, as they're indications with the systems and basically mask the degrading condition. So the local team had lost confidence in the battery monitoring system on data hall 3, and we're doing the local testing and relying on that. And as a result, the impedance was increasing on the batteries and leaving them in a degraded condition where they couldn't maintain load. So the battery monitoring system also monitors for a rate of change and reference amount of change to the initial baseline. And this is critical to assess health. So the local monitoring does not do that, and local testing does not do that. And for reference, 1 or 2 high impedance batteries, high resistant batteries in a string can disable the entire string. And since the power leaving the battery string will be consumed internally and not support the load. So this occurred in multiple strings in data hall 3, hence the UPS failures, which happened very rapidly.
Got it. That's a great summary. Thank you for that, Michael. So we understand a bit more about that initial ground fault trigger, the faulty cable, as well as the batteries. And like you say, it was kind of unlucky timing there. So I'm glad that we're having a look at our monitoring and our maintenance of those batteries to see how we can fare better, not just on this campus, but in all of our data center regions around the world. That's helpful to understand. So thank you for giving us the data center angle here. Next, I'd like to pivot to some of our kind of core Azure services, storage, networking, and compute. So maybe we'll start off with Jagan from our storage team. I know as Michael's just explained, so power's coming back online. I'm glad we took safety seriously, but once we were able to restore power, could you talk us through what that looked like from a storage perspective, starting with how this impacted customers? Did we have issues with our locally redundant storage, zonally redundant storage, geo-redundant storage? Well, what was the pain from a storage perspective? And can you talk us through the storage recovery, please, Jagan?
Yeah, so as part of the power loss in data hall 3 that Michael talked about, we lost power to 7 scale units. One of them was part of a ZRS cluster, and that did not see any impact. It failed over to the replicas in other zones. Then we had impact to 6 other scale units. Some of them were for the disk workload. As soon as the power was restored, those which were based on SSD hardware came back in 30 minutes or so. Those which are based on hard HDD, the spinning hard disk, came back in about 60 minutes, all as per design and as per our operational procedures. But unfortunately, one of the scale units did not recover. On investigation, we found that multiple networking switches in that scale unit were non-functional, and that delayed storage recovery significantly. And we had to work with the networking teams to get all those switches replaced to make that scale unit healthy. That was an LRS scale unit, or locally redundant.
Super, Magic. It actually brings us to Leroy. Leroy, for networking, we understand that device didn't come up after this power restoration. First of all, is that common that devices don't power up? It seems like a problem, but we were kind of prepared because we had replacements and there were issues there with networking, making sure the networking was back up. But could you walk us through that, please?
Yes. Actually, so majority of network devices come back automatically after power comes back, right? So I think there's a set of devices that just didn't come back completely on its own. And the networking team worked with the data center team to try power reset device, and that did bring back some of the devices. But for some other devices, a small set of those devices just are not coming back after power outage, completely dead. So we have to do the physical replacement through the RMA process with the ones in the inventory, and that took time, right? So we since then have shipped those devices back to work with the hardware vendor for deeper RCA on why those devices completely failed, right? So I think that reveals some hardware failures in the corrosion, right? And so that's a context on why it didn't come back fast enough.
Suba, and you and I were talking the other day, and you mentioned something about the clock drift and the new firmware, which I thought was fascinating and quite interesting for the story. Could you share that with our customers as well about the networking devices and our clock drift?
Yes. So actually, a networking device, right, not only serves the purpose of forwarding packets, it also serves as a boot when the server is trying to boot itself, right? You try to get the PXE and a DHCP request from the networking device. And between the server and the switch, they actually checking the clock, right? The clock drift are too large, the server will not recognize the PXE, right? In this situation, some of the switches, they have the clock has drifted from basically when the device come back, it no longer have the system clock, right? Normally, if the network device is running, it gets a clock from this system called NTP, right? So it's a system clock. But when the power fails, you have to take the clock from the motherboard, which is the RTC clock, and the clock was not it drifted on the RTC clock because we did not synchronize the clock to the RTC. Right, so and that bug caused a problem when the device come back. It's using the older clock, and it takes time for the NTP to resynchronize the clock when the PXE is happening. So that delayed the system recovery for about 20 minutes before the clock completely comes back.
That's great to understand. Thank you, Leroy. So we've covered there some of the networking devices that didn't come back online after power restoration, swapping out some of those network switches in the storage scale units, like Sammy mentioned, and then finally that clock drift issue, and we're shipping some firmware to help improve that moving forward. Okay, thank you for covering our networking, and then we'll shift over to Binit from our compute team here. But Binit, I understand there were a couple of issues encountered by compute coming back online, but before we talk to those, could you just talk us through how we recover virtual machines, generally speaking? How does this usually work after power is restored after an event like this?
Yep, thanks for coming to me. So in disaster recovery, we have a software suite called Defibrillator, which is detached from the rest of the control plane and dedicated exactly to disaster recovery in such situations. But before I get to the Defibrillator suite, in a typical situation, 99.9% of VMs are able to come back normally, provided we have power restored, we have networking restored, and we have storage restored. In this case, however, around 90%, 98% of the VMs came back normally, and 2% had a long tail of recovery. And I'll get to that in a little bit as to why it was such a high number. But let me talk a bit about Defibrillator. So what Defibrillator does is, the moment we have green signals from all these dependent services that things are good, VM should come back up, we monitor all the VMs if there are any that have not come back yet. If there are any such VMs, we go and start investigating. Again, this automated suite goes and investigates all the machines on which these VMs are hosted, and then tries to find out, hey, are these machines even running? Have they been able to boot up or not? If not, it goes through a sequence of events to boot those machines up, make sure that they're booting up and the VMs are coming up, collecting diagnostics all along the way to make sure that to understand retrospectively why the machines didn't come back automatically. And then if at any point it gets stuck, it takes more aggressive actions like healing the customer workloads from the affected machine to a healthier machine. And this does typically happen when you have these kind of outages because a lot of latent issues on machines that did not show up in normal steady state start showing up after a power outage, after a temperature trip, etc. But yeah, with that, let me get into a typical sequence of events that we expect to happen when we try to reboot the machines after a power outage. So the power outage happened. Power is restored, networking is restored, storage is restored. Expectation is the machines have booted up automatically. The software suite, Azure software suite comes up, the VMs comes up, everything is fine. In some cases, when the machines don't boot up, our first order of business is let's forcibly boot the machines up. After the machines are booted up, then we expect it to go through the bootstrapping process, the OS specialization process, bootstrapping all the Azure agents on the machine that are there to provide control plane services, and then make sure that once the VMs are up, it's heart beating, it's providing all the necessary health probes that the application has started running. In this particular situation, unfortunately, all the three steps of these expectations were sort of upended. What that means is we had a category of a set of machines that we simply could not boot up. All our operations, power operations were failing. Second category was in the cases where we were able to perform power operations, the machine was getting power, it was trying to boot up, but it was not booting into the OS. The third category was when it was booting into the OS, the bootstrapping process was not succeeding because of one of the issues that Leo talked about, time drift, where the machine is trying to establish a particular protocol with the top of racks, and they aren't able to, like, in spite of multiple retries, they aren't able to get the right information to initialize themselves. So these three categories led to very interesting and very important lessons for the entire group over here to be able to test many more scenarios and build more resiliency into the defibrillator suite.
Thank you very much, Bennett. And you said something I want to hook onto it. Could you tell us more about those lessons, those learning, and those repair items? I mean, you teed it up for me, but I'm fascinated to know what you and your team learned from this and what you're going to do moving forward.
Yep. So I'd take a slightly philosophical stance over there. So there's some, in these kind of incidents, there's some categories which you simply cannot predict ahead of time. I think the clock drift one is one which was difficult to predict ahead of time. You just need to get dirty and try to find out what exactly went on, investigate online. The other categories where we could have seen that these failures are happening and reacted to it faster. So I think the case where we weren't able, even though we realized we are not able to issue power operations to a large subset of machines, it took us a while to realize that this is happening at scale and it was affecting our recovery time. Um, so most of the learnings for the compute team over here are to increase the test matrix as to the number of scenarios we can cover. For example, if the top of rack is taking time to initialize and the machines are coming back earlier than that, can we invert that process, change the order of expected events, and test how the entire system reacts to that, and put in the resiliency at each and every point of the stack to such a upturned sequence of scenarios. We are also putting features into a defibrillator to do a better prioritization of which machines to investigate and solve for first, and react to all the diagnostics that is being collected to be able to make a more accurate repair decision then and there as to, in this case, if bootstrap is not happening, can I restart certain agents and get past that situation, find the RCA later. So a lot of these repair items, again, it's been a very good learning lesson for all of us. We haven't seen an incident of this magnitude or these many things, variables going wrong at the same time. So it's something we've taken back and we have already strengthened our suite to be able to handle it better.
That's a great summary. Thank you, Bennett. I appreciate that. So lots of different kind of impacts from the compute recovery perspective and repair items across the board there for those. So thank you for that summary. Turning our attention to some of our data services next, I'd like to bring in Debarshi from our Cosmos DB team. Debarshi, could you help us understand, impact varied according to how customers had configured their Cosmos? Could you just help us explain kind of which customers felt which kinds of pain and talk us through the difference between that service managed failover that Microsoft implements and customer managed failover that customers can do themselves?
Yeah. So Cosmos DB is a distributed database, and the data shards are distributed across different, depending on the configuration, it is spread across different availability zones. And also, if you have a regional setup, the data shards are replicated across multiple regions. So during this outage, which was for a specific region only, we did see varied impact. So the variation dependent on the configuration of the regional setup and the specific choice of consistency models that was set up. So if the customers were using the multi-AZ configuration, they did not really see any impact because automatically Cosmos DB was able to fail over to the other availability zones that were not impacted, and the customers would not have seen any impact. And on the other side of the spectrum, if the customer was using just a single region for reads and writes, and the data shards were on the impacted instances, they would see 100% availability impact. And then depending on the choice of consistency model, the impact would vary. For example, if they had the right region of South Central US, the data shards were on the impacted cluster, some of the write operations would fail, whereas the read operations would succeed. So, it was a spectrum of the availability impact that the customer might have seen, depending on their choice of consistency model and how they have set it up. So on the failure pattern and how do we recover from it, as David alluded to, we do support something called offlining, which is the service managed failover today. So today we do not provide that control to the customer to recover from an outage by themselves if there is an outage, and it is managed by Cosmos DB, and that's what we call as the service managed failover. But based on the customer feedback, where they want to get full control of when to really fail over, because there might be an implication of their app also kind of failing over in tandem with the databases failing over to other region, we are exposing that capability of offlining to our customers that the customer can exercise if there is an outage and if they are impacted by the outage. Right? In certain cases, if they are on a configuration, they might not be impacted. But if they are indeed impacted by an outage on a specific region, we'll provide that lever to the customer to be able to offline the region and then bring it back online as and when the outage has been recovered.
Cool. That's great. Thank you, Debarshi. So good to understand the different failover options and how we're actually enabling more of those to help customers make their own decisions. Well, one other quick question I wanted to clarify with you. It sounds like having the underlying storage impacted was a big reason that this was able to impact Cosmos. You mentioned that potentially you all were exploring looking at ephemeral disks and whether that can kind of help remove some of the dependency on storage. Is that a long-term play here for Cosmos?
Yes, absolutely. Thanks for bringing that up. If you look at the failure pattern during this outage, we really had two different paths of failures for Cosmos DB. One failure pattern was due to the hardware, the power going down. We had a bunch of our compute clusters going down altogether, and we just didn't have those clusters available to take on a traffic. So that was one type of outage. The other type of outage that we had was our dependency of the operating system drive for the VM. Today, for some of the configurations, the operating system or a drive for the VM is on the storage account. And because storage was also impacted by the power, we had this transitive impact where some of the VMs went down because the operating system was not available anymore. So to get out of that problem, what we are working on is what is called as the ephemeral disk, where the disk would be carved out from the host itself, and we would not have a dependency on storage for the operating system drive. That is something, this work is in flight. In fact, all the new compute clusters that Cosmos DB is creating is on that configuration, and we are working on a process to do the in-place migration into that configuration with the intent of getting everything moved over by the end of this calendar year.
So super, thank you very much, Debashis. I'd like to pivot to AJ. AJ, in a similar way that Cosmos had different impact depending on customer configuration, the same was true for SQL. Could you walk us through the different types of impact? But also I'd like to know what advice we can give our customers for the best resiliency options. What are the best BCDR practices? How can SQL customers best survive things like this?
And like as you pointed out, Sami, the impact to our infrastructure was very similar to what Debashis described. And South Central, we have two classes of deployments. One which are like regional, the LRS, and then the second which are the zonal resilient deployments. And as we expected, like the zonal deployments, and customers who had opted for zonal configurations didn't see any impact, and it's the problems like beneath and with the OS disk, the regional deployments, databases which were on regional deployments saw the impact, and then of course the duration of the impact was for the reasons that they pointed out, Beneath and Cole.
Got it. That's helpful to understand kind of how different customers had configured them, that correlated to their impact. And in the follow-up there around our general kind of resilience guidance, what advice does SQL generally give when it comes to high availability or BCDR? How could customers have configured to avoid this, even at a high level, Ajay?
Right. So I mean, I think there are sort of broadly two things that that customers need to think about, right? And one is, of course, like the zonal resiliency. How much availability do you want just being within a region? And then how important is it for you to get reliability if there is a regional wide outage? And that's where customers should sort of think about GeoDR, which is geo-replicated databases. And as Debashis was sort of pointing out, when you set up sort of GeoDR, it is not a simple choice. It's not like okay, I'm going to enable a configuration and suddenly my entire stack is resilient. You have to account for the fact that there are replication lags. So when you do failover, you might end up losing some amount of data. There is the entire application stack, which needs to be resilient to either you move the application to the other region or be able to point to the databases in the other region. And it is something that you must practice regularly. It's not like the first time you'll be able to try it will be in an emergency. So those would be my suggestions.
Super, Magic. Thank you very much for the resiliency guidance. I know we captured a lot of that stuff in kind of WAF, but it's great hearing from you on how SQL customers can best leverage this. Karthik, I'd love to turn our attention to Synapse if I can. What was fascinating for me about Synapse is that customer impact was small. It was less than 1% of customers, but the impact of Synapse extended beyond the zone, not only beyond the zone, but beyond the region as well. Could you walk us through this? This is a fascinating case.
Yeah, thanks, Ami, for bringing it up. Yeah, Azure Synapse Analytics, like Spark, a part of the Azure Synapse Analytics, we provision on-demand compute using Azure Resource Manager. Azure Resource Manager, does some RBAC checks on the resources that we provision, like making sure that we have the right permissions needed to create these resources in our subscriptions. And we learned that ARM has this RBAC, backing store, placed in Cosmos DB, and that is globally replicated. And during a request, it can be routed to any close proximity regions, like because it's globally replicated, some part of the calls can land in the alternate regions close by. So we have seen that issues in Brazil South, the request originated from Brazil South and East US too. Some part of the requests are getting redirected to South Central US, where we had a power outage, and the RBAC store was not able to process these requests, and the calls were failing out in the ARM. We root caused it, like at least with the ARM team, to figure out like what could be the reason for what could be the reason for not falling back to the alternate replicas. Because if the South Central was not available, then it should be falling back to the alternate regions like configured. Like for example, it can go to the Brazil South again, or it can go to the East US too. But it did not happen in this case because of the way that the fallbacks are getting tried in the SDK of the Cosmos DB. The cancellation token that was being passed is like getting expired before the fallbacks can kick in. There are a few repair items that were identified through the ARM team that the teams are focusing to fix them. They're also working on a new feature called request hedging that will concurrently send the request to all the regions at once, and whichever region is responding back, they will honor that response. So hoping that next time this happens, we'll be able to have all these fixes in, so that in case of any power outage and all, the call should be landing into the healthy region.
Cool, that's great. Thank you, Karthik. You might need to put $1 in the root cause jar. We try not to talk about root causes here because actually this incident demonstrates beautifully, what was the root cause of this issue? Well, we could say it was the power outage. We could say it was battery faults. We could say it was some of these issues with compute or storage coming back online. And so obviously when we see the breadth of this conversation, it becomes pretty clear pretty quickly why we try to look for, as many different contributing factors as possible and not a single root cause. So thank you for that. Great summary on Synapse here and the impact beyond the region. I'm glad Synapse and ARM are partnering together to ensure that these kinds of things don't impact multiple regions. That's great. So next up, I'd like to move over to Manish. Manish from our Azure Site Recovery team. Obviously, ASR is one of the many tools that our customers use when it comes to business continuity disaster recovery. So Manish, could you help us to understand how did ASR do during this outage? And more generally, how can folks use it to survive these zonal or even regional incidents?
Okay, thanks, David. So ASR, as you said, is designed to build resilience in Azure. So customers use ASR to stand against these zonal or even regional outages. So a set of customers who were using ASR and during this power outage, when they exercised their failover to the other zone, they were able to successfully recover their workloads, critical workloads, into the other zone which were up and running. So I'm happy to tell every single failover was successful during this zonal outage.
That's great to hear that generally speaking, ASR was able to come to the rescue of customers who needed it. And more generally speaking, would you give us just a kind of high-level summary of the ways in which customers can use ASR to fail out? Because I know initially it was just for failing out of a region, but more commonly you can now use it even to fail out of zones. Is that right?
Yes. So ASR provides both zonal replication as well as regional replications. Customers can use it for either of the two. And in this case, it was a zonal outage. So customers who have configured the zonal replication, they were able to successfully move to the other zone, which was healthy. Customers who were using the regional replication, they could have actually, a set of customers moved out from South Central US to their DR region to move their critical workload to the other region and continue running their business. So it can be used in both of the configurations.
Super. Thank you very much, Manish. It's super helpful. Eunice, I'd love to turn our attention to you. I think this is a fascinating piece. Eunice, you've spoken to us in the past about zonal issues that have spread beyond one zone. I'd love to ask you a kind of a double-barrel question. The first one is, how did our services and our platforms respond to this partial zonal outage? And then what are the things that we can do for customers, or what can we recommend to customers in order for them to be resilient to these types of things?
Thank you, Sami. What we've seen through this incident and other incidents is that regardless of the cause of the failure, the best way for an application to insulate itself from single zone failures is to use zone resilience queues. Zone resilience queues of products like Cosmos DB, SQL DB, VMSS, many of these. The advantage of using a zone resilience queue is that then the resource is spanned across multiple zones and is inherently resilient. When one of the zone is impacted for whatever reason, it could be power reason here, it could be another reason somewhere else, it doesn't matter, but the application and the resource stays up because of the other two zones that are not impacted. That's exactly what we noticed in this incident as well. Yeah, the root cause was, say, it started with power and there were other implications as well, but didn't matter. All the Cosmos DBs that were zone resilient, the SQL DBs that were zone resilient saw zero impact. And the applications that used those versions of Cosmos DB and SQL DB or VMSS were not impacted as well. So Sami, our recommendation stays the same that it has always been, which is for customers to continue to use the zone resilience queues and use those in the workloads, especially the critical workloads. If something is a dev test workload and you don't use a zone resilience queue, I could understand. But especially for the production and the critical workloads, I would say it's really important to use the zone resilient workloads. That's how you guarantee high availability.
Got it. That's very helpful, Yunus. So I think even though, zones is absolutely the strategy here, and for a lot of services, zones, help customers to survive the storm. Obviously, there are a couple of issues that we've already touched on, but that doesn't change our recommendation for customers to be using availability zones precisely to avoid, power, networking, cooling issues that besiege our data centers. So that's a great summary. Thank you for joining us, Yunus. At this point in the conversation, I'll generally turn my attention to my co-host. Sami runs our Azure communications team. And so beyond talking to our experts from the various impacted services, my question is naturally, how did we do from a communications perspective? Did we keep our impacted customers up to date? And do we have any learnings or repairs about our communications?
Super. So to kind of run through what happened, we have our brain, which is our system that auto-communicates to customers within 15 minutes of impact. We usually get a little bit less. This fired at 6:46 p.m. For Cosmos DB. App services followed 5 minutes later. Compute and virtual machines was 2 minutes after that, and so on. So most of the services that we have that are onboarded to Brain, customers would have received a service health alert if they configured them, but they would have been communicated to behind the north wall. Generally speaking, we like to if we can communicate to impacted customers and not go broadly, we will. However, we saw that impact was growing. Different services were coming on saying, hey, I'm impacted as well. And so we decided to go to our status page around 8:54 p.m. As impact was growing. We did call out there was a power event in a single AZ, and we called that out as AZ03. There is an API that can help customers understand how their subscriptions are mapped. We were sporadic in using it, which is definitely something we want to be consistent about. An interesting piece is we advise customers to kind of fail out of the region. And it's a bad thing to do. We shouldn't, our position in the communications team should be to arm our customers with as much information as we have. We know there's a power event. We know it's in one AZ. We think if we don't have an ETA, we can give you a window. Say it's not going to be mitigated in the next 6 hours. And while we don't have an ETA, we can at least bank on the next 6 hours. It'll be down. We need to offer information like this to our customers so they can make decisions. And I think we want to step away from the idea of advising customers. They have different people in their own organizations. Some customers can survive a 5-minute outage. Some customers can survive 5 hours. Some customers can maybe even survive a multiple-day outage. But the idea is that we shouldn't dictate to customers their fail-out strategy. That's something they should build into their BCDR plans, and they should be able to execute with the information that we give. At around 6:30 in the morning, when we saw recovery in most of the VMs, 5 minutes later, we started talking to our customers and telling them that we had recovered. I think we could have done a better job in keeping our customers updated with what was going on. And we ended up over-communicating, as we tend to do with these kind of events. And one of the repair items is really to say, we're able to communicate to all customers in a region quite well, but we haven't quite got it down to per zone. And because some of the way that Azure's architected, where there's kind of ubiquity between data and zones, that becomes a problem as we communicate. But it's investments that we're making in that space.
Got it. That's great. So some services had that really quick communication come out thanks to Brain and the investments in Brain we've been making, but maybe some improvements on the comms content, giving customers advice on whether they fail out or not. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get post-incident reviews after an outage, and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alert set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.